Thanks, Richard. So being a part of Boeing and being involved in this commercial space has been interesting. In some circles and for whatever reasons, depending on what definition you choose to use for commercial space, people don't look at Boeing as being a part of that. So that's interesting. Half the company is in a business that's pretty involved in the commercial transportation of people. Many of you probably came here on one of those vehicles. So it's just a different thing to be in. So what is commercial? Clearly, there's a lot of definitions. It's a different way of contracting, it appears. Perhaps a different way of having a relationship with NASA. But however you look at it, it's an interesting new approach, and it's an exciting thing to be in. I agree with Larry. This is a really exciting time. Things are in transition. Things are changing. I think it's really important as we go through that change that we keep an eye on protecting the capability and the skills that we've built up through the 40 years of human spaceflight, or however long that has been, and we keep a balance there, and we don't jump so quick that we lose where we've been. So I've got a couple of charts here and some thoughts on commercial involvement in Mars, but it'll focus on keeping a balance between the aggressive new approaches that we're taking, but not losing the good things that have come from the past. So I have a few charts just to show what Boeing is doing in the commercial arena, and then I'll share those thoughts with you. Okay, so next slide, please. So this is the capsule that we're designing. It's called CST-100. We chose to take a pretty low-risk development approach here, focused just on the spacecraft, and use a proven launch vehicle so that we could limit the development risk. Carry up to a crew of 7. Currently we're focused on low Earth operations, low Earth orbit operations only, and that is what the design point focus is. All that allows us to, by keeping this thing simple and focused on that mission, we can have it be focused on being safe and reliable, low-risk development, and low operations costs. So those are kind of the mantra of our design team is to keep those in front of us. Currently, we're designing this for the environments of several launch vehicles. Larry will recognize the one on the left, and then the others are shown there, the ULA rockets, the ATK rocket. We're in the process of down selecting to a single launch vehicle so that we can have it do the details of the design through the abort process, things like that, and we need to get a single launch vehicle to do that. But we'll maintain the overall environments that we're designing to so that later we could do that point design and be compatible with any of the rockets. Okay, next slide. So the op scenario for a commercial crew, NASA has indicated they want to procure a turnkey system. So we're putting in place an integrated spacecraft and launch vehicle. We'll be able to rendezvous with a low Earth orbit platform such as ISS or Bigelow's Space Complex. Stay on orbit for up to 6 months with a month of contingency to perform the crew rescue mission if that's necessary. The spacecraft deorbits then, the service module burns up on re-entry. We land on land with parachutes. The capsule can be refurbished for up to 10 missions. And then part of our system is a control center, ground processing capabilities so that we can perform all the functions, including crew training, that are necessary for a turnkey system. Next slide. This is the schedule we're working to. We just completed CCDev. NASA was scheduled to announce today the CCDev 2 results. I got an email just before I came in that that's been delayed indefinitely as a part of the CR discussion, I assume. But anyway, we're standing by to hear about CCDev 2. During CCDev 2, we'll take our design to PDR, a good portion of the way to CDR, and then we anticipate that there'll be a development completion phase that NASA will have a procurement for that will follow CCDev 2. 4 test flights are part of our program: a pad abort test, an uncrewed orbital flight test, and an abort test that happens at maximum dynamic pressure, max Q. And then finally a 2-crew flight test, which is currently baselined with 2 Boeing test pilots, although we'll be in discussions with NASA about whether we should do that with NASA crew. And then we're scheduled to be capable for operations in 2015. Okay, next slide. Just some of the progress we made during CC Dev, and for time constraints I won't go through the details of this, but we did several landing bag drop tests, uprighting tests in case the capsule lands in what's called stable 2, nose down. Integrated the life support system to verify it could handle a metabolic rate of 7 crew. And then we built a mock-up of the module to work on ingress, egress, and displays and laying all that out. Next slide. Fabricated a heat shield out of a new material that our team in Huntington Beach developed. It's a low-cost way of fabricating a heat shield, since in our design it's disposable for each mission. We fired our abort engine, built a pressure vessel test article. That went from design to fab and test in 9 months. It's a really innovative approach. It has no welds in the structure. There's one seam that's put together with a Gasco seal similar to the one used on Space Station, and it's a bolted joint. And then we built using the Orbital Express automated rendezvous and docking software, we built a simulator and tied it to a motion-based simulator so we can close the loop with video as we approach a mock-up of the pressurized mating adapter on the station. So a lot was accomplished in a short amount of time with not a lot of money in this kind of an environment we're working in. Okay, go ahead. Okay, so some thoughts on commercial applications for beyond LEO. There's a unique environment, I believe, that exists in LEO right now that's enabling what we are calling commercial applications to enter there. So a foundational customer exists. NASA wants to procure transportation to ISS, so there's a base there for a business. And there's significant potential for upside beyond that. Space Adventures is a good example of that, and we're also teamed with Bob Bigelow, who's putting Bigelow Space Complex in orbit and dealing with countries that want to have their own space program. So there's a significant potential upside to this foundational market. The mission is well understood. We've been going to low Earth orbit in capsules for a lot of years, so we understand that mission. It's a repetitive mission, so we can get good at that. And the design can be focused on that mission. There's not a lot of new technology, particularly not a lot of new operations kinds of technologies that need to be put in place to do this. So the problem is understood, it can be bounded, there's a customer base there, and these things enable commercial entries into transportation to LEO. Beyond LEO is more challenging. The mission durations are longer, so it's technically a more difficult problem. The distance and time to return, if there are problems, is a bigger challenge. Some new technologies are required, radiation hardening, radiation protection of the crew, and a lot of operational challenges are associated with things like comm delays, logistics challenges, things like that. So the problem is more challenging than the LEO problem. So there's more risk involved in developing beyond LEO, and at present there's not a commercial market that's really envisioned or described for beyond LEO. A little different scenario than what we see for the LEO transportation market. Next slide. There's also a couple things I think we need to keep in mind as we debate this for the survival of this infant commercial venture, is what I guess I'll describe it. The political solution that's on the table right now is a solution that's balanced between commercial providers focusing on LEO and government-led NASA missions focused on beyond LEO exploration. So that's something that Congress really debated. The commercial part of that, I think, survived because of that balance. And as we talk about moving beyond LEO, we need to be careful not to upset that balance and kind of lose the whole thing. I guess another thing I would point out is that I think the commercial providers, the developers of capability, are really dependent at this point in time on the expertise and the talent that's coming out of government-led programs. I know in our situation, we're really leveraging people off of Space Station and Space Shuttle to do the development work on CST 100. And because they have that experience, we're able to do this in a very cost-effective and timely way. Without that kind of pipeline of talent being fed to the commercial providers, I think the development challenge is a lot more significant, a lot more costly, and will take long. So this balance of having government-led programs focused on LEO, keeping that pipeline pumped, and then as things, as the technologies and the missions become more routine, commercial move into that is a nice balance, at least for this point in time. So I'm sure that others will have other comments on that, but I think it's important we keep it a balanced discussion. And I really think that the commercial provider community at this point in time is best served by focusing on the LEO problem, proving we can do that, and then branching out and discussing about moving commercial providers into exploration beyond LEO. So look forward to questions and discussion on that.